and today we're going to start section 2 of chapter 2, and this is going to be solving a solution of linear systems just like before, but with a different method called the Gauss-Jordan method. Okay, so the last method was the echelon method, okay, using transformations and using row operations, and the Gauss-Jordan method is very similar to that one, okay, but also in some ways simpler, okay? But it uses the idea behind the echelon method. Okay, so let's begin. So the question that I have is, how can an auto manufacturer with more than one factory and several dealers decide how many cars to send to each dealer from each factory, right? So you've got factories that are in different locations. You've got all dealers that are in different locations, right? So you're looking at a geographical kind of three-dimensional thing going on here, right? So, well, depending on how far each dealership is from a plant, right, a manufacturing plant, so how do you decide, how does a company decide where to send from which manufacturing to which dealer? Well, that is the type of question that we can answer using systems of equations, okay? So let's look at this very generic system of equations. So let's say we have this system of equations. Well, this is what we were looking at before. Well, look at the way this is set up. So we've got the x's, right, in one row. We've got the y's in another row and the z's, right? So we've got an alphabetical order. And so we've got equals and we've got all the constants on one side. So variables on the left, constants on the right. And we've got all of the variables lined up, okay? Well, if that's the case, remember those three transformations? Well, those three transformations do not mess with the order of the variables. Every single time we do one of those transformations, we end up with a system of equations where the x's and the y's and the z's are all in the same column, if you will. So what we can do is we can ignore the variables, and so we can simplify our expression by just writing down the coefficients and the constants, right? And then what we can do is we can create what's called an augmented matrix, right? So this is what we're going to look at as a matrix. So, but what we're going to do is we're going to get rid of the equal signs. So let me look here. So what we're going to do is we're going to get rid of the equal signs and replace it with a vertical bar. Okay? And so we'll have a matrix which is called an augmented matrix, and the augmented matrix separates the variable side from the constant side. And so we'll have three rows in this case of numbers which represent the coefficients. So we got 2, 1, 1. So there's the 2, 1, 1. And then we got 1, 3, 1 right here. And we got negative 1, right? Minus a negative 1, 2, and 1. And then we got the constants. Okay? And so then what we can do is we can just look at this system of equations as a matrix of numbers. Okay? Now, here are the row operations. So these are what we call elementary row operations. So for any augmented matrix of a system of equations, the following operations produce an augmented matrix of an equivalent system. Remember? So again, this is very similar to the idea behind the echelon method, right? So two different methods, same idea. So look at this. We can interchange any two rows. We saw that before. 2, multiplying the element of a row by a non-zero real number. And then 3, we can add a non-zero multiple of the elements of one row to the corresponding elements of a non-zero multiple of another row. So these are the three same transformations that we saw before, but now we're going to call them row operations. Okay, these are what we're going to call the elementary row operations, or sometimes I call them ERO, elementary row operations. So now let's look at this one. So let's use the Gauss-Jordan method to solve the system. So here's how it works. We're going to take this system and we're going to rewrite it as an augmented matrix with just the coefficients and the constants. And then our goal is we want to put it in this form. We want everything to be zeros except the diagonal. We want ones along the diagonal and then everything else to be zero. And then what happens is the numbers on the right side of the vertical bar will be the solution to the system. Okay, that's the power behind the Gauss-Jordan method. Okay, so it takes the echelon method one step further because in the echelon method you had to get a triangular form and then use back substitution. Well, with the Gauss-Jordan method, as long as you solve it where you've got this matrix on the side where you got zeros everywhere except the diagonal here, which is along the diagonal, ones, so you have to have ones, then everything to the right of the vertical line are all your solution. It's your solution set, okay, or your solution vector, if you will. Okay, so now let's start with using the first row to change the 4. So the first thing we do, it's a little bit different than the echelon method that we did. So here we take the leftmost variable in the top row. So we want this to be a 1. That's the first thing we want to do. So we want to change this to a 1. Easiest way to do it is multiply this by a 4th. Okay, so we're going to divide everything by 4. So we're going to take row 1 and multiply it by a 4th and then replace that with row 1. So we're going to replace this with row 1. So now we get 1 and we get 5/4 and 5/2. Okay. So now that we got a 1 here, now we're going to use this to get rid of this, to make this a 0. Well, then we're going to take what? We're going to take -7 times this row and add it to this row. Or you could take 7 times this row and add it to -1 times this row. It's the same thing. Typically, I would just multiply this by -7, add it to the second row, and then replace the second row with what I got. And so, again, that's what they did. Okay, so -7 times row 1 plus row 2, and so we're going to replace this result for row 2, and we get 0, and we get -3/4, and we get 3/2. And now we're done with this column. Now we want to go to the second column, and now we want this here to be a 1. Now that we got the 0, now we're going to look at this row, second column, and we're going to want this to be a 1. Well, how are we going to get this to be a 1? Well, we want to multiply this by some number that's going to give us 1 here. Well, the easiest one to do is the negative reciprocal, the reciprocal of this, right? If we multiply this by the reciprocal, -4/3, well, -4/3 will give us 1. Hold on a second. There's a typo here. Yeah, this is a typo. This is -4/3. This should be -4/3, not 3/4. So if you take -4/3 times row 1, you will get, and then replace that with in the row 2, you will get 1 and -2. Okay, so this is just a typo. This is the correct answer, just this is a typo. Because if you take -4/3 here, you get -2. So this is correct. Okay, so let me change this back to highlighter. Okay, so now this is our matrix. Now the last step is to use this here to make this 0. Well, how are we going to make this 0? Well, we can multiply this by a negative 5/4. So multiply this by negative 5/4 and add it to row 1 and then replace row 1 with the result. And so when you multiply negative 5/4 and you get, now you've got this here, and now these are your solutions. So that means your what? Your x is equal to 5 and your y is equal to negative 2. Okay? And so now your solution is 5 comma negative 2. So the solution can be read directly from the last column of your final matrix. So the idea is you want to get this matrix here. This is called the identity matrix, just so you know. So you want to do as many elementary row operations in order to get the identity matrix here. And then once you have the identity matrix here, your solution is the column to the right of the vertical line. And you're done. Now on the graphing calculator, so this can be done on the graphing calculator easily. It just takes getting some used to. Okay, and I'm going to go through it here, but then we're going to do this in class. So don't let me forget this, but we can do this in class easily, and then it's just practice. Okay, so try to do this on your own, and if you get stuck, just let me know in class, and I'll be more than happy to go over this and show you guys how to do this in class. So let's take this matrix here. Okay, and let's say we want to find out, and this is an augmented matrix, so let's say this is the variables and this is your constants. Okay, so you have to have an augmented matrix when you do this. So we want to first make sure that the system is entered correctly and everything's in the proper form. Okay, so this is x's, y's, and z's. So now what we want to do is we notice that the first term is already 1, so there's nothing we have to do. So all we have to do is get rid of the 3 and the 1. Well, the way we do that is by using the calculator. Is we're going to use under the matrix menu. So if you go to the matrix menu, you're going to hit the matrix menu and you're going to go to math. And under math, you're going to do this function right here, which is called star row plus, which means you're going to multiply by a row. You're going to multiply the row, some row, by a number, and then add it to another. So what are we going to do? Well, in the parentheses, when you select this function, you have to first say, okay, what am I going to multiply by? Well, I'm going to multiply by negative 3. And what matrix are you going to use? What matrix are you working with? And in this case, it's going to be matrix A. If you notice, this is matrix A. Okay. And so we're going to multiply. This is what we're going to multiply by. This is the matrix we're using. Well, what are we going to multiply negative 3? What row are we going to multiply negative 3 by? Well, we're going to multiply row 1 by negative 3. And then what are we going to do with that? We're going to add it to row 2. So this is the one we're multiplying. This is the one we're adding to. And so we're going to take negative 3 times row 1 and add it to row 2. And then we're going to replace the new row in the new matrix. So basically we're going to replace row 2 with whatever we got. And then once we do that and we hit enter, the calculator will give us our new matrix. So notice, look, it's all 0. And these are the new numbers. Okay? The other 2 rows were left unchanged. So now we're going to do the same thing to get rid of this one and put a 0 there. So what do you think we're going to do? Well, we're going to what? We're going to take negative 1 times row 1 and add it to row 3. So this will be negative 1. A. We're going to add it to, we're going to multiply by 1, but then we're going to add it to 3 and do the same thing. And so notice that's what we have. And so now we get 1, 0, 0, and this is our new matrix. So far so good, right? Now we're done with, we got rid of these, so now we're done with this column. Now we have to go to this one. So this one we have to make a 1. Well, guess what? We're going to multiply, we're going to divide by 6, or in other words, multiply by 1/6. So now we're going to use a different function. That function is going to be just the star row function, so we're not going to have the plus. So there's another function under the matrix menu for math, and it's going to be star row. And so here's a star row, and now we're going to multiply by 1/6. Again, we're working with matrix A, and which column are we multiplying? Or excuse me, what row are we multiplying by 1/6? 2. And so then we're going to store, that's where we're going to, this arrow comes from, we're going to store this in matrix A again. And so once we hit enter, we get this matrix. Now, we don't want to deal with decimals, okay? So in order to get rid of the decimals, we're going to use the frac option on our calculator. So what you have to do is you have to use the answer. So this is our answer. And we use answer, and then we use the frac option under the math key. And then we hit enter, and it changes our matrix to all fractions, okay? And now what we want to do is, now this is our 1. So now we're going to use this to get rid of this one and this one using the same technique that we did when we're getting rid of these, okay? So here we're going to multiply. This one we actually just have to add, right? We just have to add these two columns. So we're just going to take 1 times this plus this and then replace this one, okay? And then once we get rid of these two and we get rid of these two, eventually we're going to end up with just the identity matrix. Again, we've got a diagonal of 1s, everything else is 0. And so now this is our solution. So our solution is 1, 2, -1. Okay. So again, make sure you do that example on your own, and we will do it in class as well. Just make sure you remind me. Okay, now here's the method for using Gauss-Jordan. So here's the Gauss-Jordan method. So 1, we're going to write each equation so that the variable terms are in the same order on the left side of the equal sign and the constants are on the right. Okay. Once it's in the proper form, then we're going to drop the variables and write the augmented matrix that corresponds to the system. And then 3 is we're going to use our elementary row operations to transform the first column so that all of the elements except the element in the first row are 0. Okay? And that the first element of the first row is a 1. And then 4 is we're going to use the elementary row operations to transform the second column so that all of the elements except the element in the second row are 0, and that element in the second row is 1. And then 5, we're going to use the row operations for the third column to do the same thing. We're going to make all of the elements in the third column 0, except for the element in the third row. And we're going to keep doing this over and over again until we reach the end, the last row, and that we have the identity matrix on the left side of the vertical line. Once we have the identity matrix on the left side, our solution will be on the right side of the vertical line, and we're finished. Okay. Now the only difference here is they wait till the last step to multiply each row by the reciprocal in order to get the 1s. But again, just like in the last example, the first step is to make them 1s first, and then use that 1 to get rid of the other terms. It's much easier to do it that way. Okay, so let's use soda sales as an example. So it says the convenience store sells 23 sodas one summer afternoon in 12-ounce, 16-ounce, and 20-ounce cups, which they call small, medium, large. So the total volume of soda sold that afternoon was 376 ounces. So we know that there were 23 sodas sold. We know that the total volume of soda that was sold was 376 ounces. So the question is how many sodas, how many of each size of soda was sold. Okay. Now also suppose that small, medium, large have different costs, right? Small is $1, medium is $1.25, and the large is $1.40. And so we also know that $28.45 in total sales was earned off of those 23 sodas. So the question is, how many of each size did the store sell? Okay, well, we know how many sodas there are. We know the volume, the total volume of the sodas that was sold, and we know the price of each soda and the total sales. So we've got everything we need to create 3 equations with 3 unknowns, which is the number of smalls, mediums, and larges that were sold. Okay, so let's use the constraints. So we know that there were 23 sodas sold, the total volume was 376 ounces, and the total sales is $28.45. So here's what we have. So we know small, let's X, right? Let's let X be the number of small sodas. Let Y be the number of medium, and Z be the number of large. And we know that the total number is 23. We know the volumes of each and the total, and we know the prices of each and the total. So let's use this table to set up these 3 equations. Well, we know that the sum of all of these sodas has to equal 23. So that's where this equation comes from. And since we know that each one of these smalls is 12 ounces, and so on and so forth for the medium and large, that if we take the number of small times 12 ounces, that's going to give us the total volume of small. And then likewise, the total volume of medium and the total volume of large. And so if we add up all of these products, we get 376. And then finally, we do the same thing for price, right? We take the number of small times how much the price of each small, and the number of medium times the price per medium, and so on and so forth. And we know that then this equation comes into play. And so now this becomes our system of equations. Okay. So now what we want to do is we want to use this system and the Gauss-Jordan method of solving the system of equations to find out what x, y, and z are. And so this is our augmented matrix. And now if you use the Gauss-Jordan method, you will be able to transform this into this. And then we know that there were 6 smalls, 9 mediums, and 8 larges sold that afternoon. Again, make sure you try to do this on your own, and if you can get it, great. If you get stuck or you're not getting the right answer, bring it to class, ask me, and we'll figure out together how to do it. Okay? And make sure you do it both ways. Do it by hand, and then do it using the calculator, because you will be responsible for making sure you do this by hand. Okay? You must be able to do these methods by hand. Okay? Unless otherwise stated. Okay? So again, do this and make sure you're able to do this in class. Okay, now that's the end of section 2. Again, make sure you're doing these on your own. Make sure you're watching these videos. If you've gotten to this part, you have. And also make sure you're writing down your questions. Make sure you're taking notes. Make sure you bring those questions and notes to class, and make sure you're doing the examples on your own. And then we will do more practice in class. So see you then. Have a great day, and I'll talk to you later.